Okay, this is extra example for magnetostatic. I just want to show the extra example. Okay. Okay, the question mentioned that consider two filamentary wires with cylindrical cross-section as figure below. So I will show you this figure. So this is two filamentary wires with cylindrical. This is cylindrical cross-section. So the diameter of the wires, this is the diameter of the wires 4 mm. So the wires centered at the origin, this is the origin, carries a current of milliampere. This is milliampere. Okay, this is current 5 milliampere. While another wire centered at, so another wire centered at 400 coordinates carries the return current. So this carries a current of 5 milliamp. This is the return current from this one, 5 milliamp. Okay, so we need to apply Biot Savart Law to determine the magnetic field intensity H induced by the two infinitely long wires at point 200. So where is the point 200? So the P point is here. This is the P point. So we need to apply Biot Savart's law to determine the magnetic field intensity at this P point. Okay. So the first step is, because we have two wires, so we need to consider magnetic field intensity from this first wire and from this second wire. But because of the distance is same, I just consider it as H equal to 2H1. If the distance is not the same, okay, this is the same. From this one to this one is 2 centimeter. From this conductor to this point is also 2 centimeter. If it is not the same, you need to calculate 2 times. This one and also this one, 2 times. You cannot do like this. Okay, so this is the distance from the first conductor to the P point, and then this is the distance from the second conductor to the P point. So we need to apply Biot Savart's law. This one is the general equation of Biot Savart's law. So we know that dl we need to use dlz, because in the question show that this is to z direction. So we need to apply length of z direction. So dlz refer to the table in the appendix is dz. So next we need to find, we already know that dl is actually dz. So we need to find r vector r. So distance vector r is 0.02, which is 2 centimeter, minus 0. This is the point. Okay, 0.02 minus 0, ar, plus 0 minus 0, ay, but I don't write it here because it is just 0 value, and then 0 minus z. we cannot put 0. We need to put Z because the wire is along the Z axis. So 0 minus Z, A, Z. So we got this 0.02 AR minus Z, A, Z. So how to find the magnitude? So the magnitude is equal to 0.02 squared plus Z squared. From here, Z squared. And then set. Okay? Square root. And then we already have the magnitude and the distance vector. And then we need to do the cross product. Okay. Cross product is like this. So you will get this answer 0.02 dz AC. Okay, this cross product you can refer to table in the appendix in chapter 1. Next, you just need to add to substitute all the equation and value that you got just now. So put in this equation. So you already have the L cross product with R. Put it here. Okay, the answer, put it here. And the magnitude, put the magnitude here. And then you get this one like this. Okay, so we can bring 0.02 and direction in front. Okay, and just left here integration towards dz. So you need to make an integration towards dz. You will get like this. Okay, so after you solve it, you will get 39.79 milliamp over meter. This is just the mathematics. Okay, and then because of the H equal to 2H1, because of the two conductors with the same distance from P point, so you need to multiply by 2 because the H is only the same. The answer is 79.58 AV milliamp per meter. Okay. Actually, they have another question here. Determine the corresponding current density J on the surface of the wire centered at the origin. So you need to determine the current density J on the surface of the wire.